Welcome to the LemnaTec Academy. In this video, we will look on the LemnaTec system from a data maintenance and system administrator perspective. This video is probably not for everyone. However, at each installation, at least one should familiarize her or himself with this topic. Let's start by having a look at the data structures of the LemnaTec system from an operating system perspective. First, we have the LemnaTec data folder. This is usually the drive L if we have a database server, or D if the database is running locally. The LemnaTec data folder has 5 subdirectories. The data folder contains all data imported into the system. You must not alter any files inside this folder, except by means of Lemna experiment. The incoming and backup folders play an important role in the process that imports the data into the system. More on this in a moment. The log folder contains various log files, including those from the import process. The info folder is used to exchange information between the database and Lemna control. There's one thing all these folders have in common. You must never ever change any files in them except by means of Lemna experiment, in particular not in the data folder. If you change files here, it may result in data loss. And finally, we have a Postgres database running on the server or locally on the control PC. If Lemna control records images, these are buffered locally on the control PC. Once the recording is securely finished and the LemnaTec data folder is available, these data files are copied to the incoming folder. This may take a couple of minutes to make sure that all files are written and copied completely. There's another process on the server side. This process checks the incoming folder every 5 minutes for new files. If there are new files, these are checked and then copied into the correct places in the data folder. At the same time, corresponding metadata is written to the database. But this process does a bit more. It moves the original data from the incoming folder to a subfolder of the backup folder. This is done to have a backup if something went wrong during the import process. In such a case, we could inspect the backups and try to fix it, or at least understand how to avoid this in the future. This requires usually a LemnaTec engineer. You find these copies in subfolders of L backup imported and L backup with errors. All recordings which have been imported without detecting any issues go to L backup imported. All other recordings go to L backup with errors. However, this strategy also increases storage requirements. In the worst case, it could double them. One last remark on the incoming folder. Sometimes data transfers are incomplete and never gets completed. In these rare cases, and only in these cases, you may remove the respective subfolders from the incoming folder. Make sure that these folders are at least a couple of days old. In order to maintain all this, we have a couple of background processes running on the system. The first I like to mention is the cleanup process. On new system, this is disabled at first, so we can't lose any data while you still familiarize yourself with the system. As I just told you, we have this backup folder and its content may increase the storage requirements significantly. Therefore, the cleanup process removes old files from the backup folder. This is done once per day. This process has 2 parameters, the short keep time and the long keep time. All files older than short keep time are removed from L backup imported, and all files older than long keep time are removed from L backup with errors. We recommend 30 days for the short keep time and 90 days for the long keep time. But the actual values are your decision. We will do this configuration at the end of your software training process. We will enable the cleanup process then as well. The other background tasks are create jobs. will create analysis jobs based on the rules defined in the automated analysis section of Lemna experiment. It runs every 5 minutes. Archive improves the speed of creating archives of experiments if you have a dedicated database server. It restarts every hour and waits for the next hour for experiments that shall be archived. Daily performs some maintenance tasks like creating missing thumbnails and, very important, create backups of the Postgres database. More on this in a second. It runs once per day. Hourly collects some data for Lemna control and can optionally create a database backup. More on this in a second. It runs once per hour. Cache update refreshes some cache files which are used to improve the performance of Lemna experiment if we deal with large amounts of data. It runs once per day. You may enable or disable each of these background tasks individually. If the server runs Linux, then these backup tasks are executed using cron jobs owned by the user LemnaTec. If the server runs Windows, then we use the task scheduler to trigger these jobs. This covers also the single computer setup of laboratory systems. You find these database backups created by the daily or hourly background tasks at ldata.db backup. Therefore, if you copy ldata to a backup location on your network, then you have a backup that includes all relevant data. We can have these backups done hourly, daily, weekly, and/or monthly. Each creates its own set of backups and has its own set of parameters. All of them have the number parameter. This parameter defines how many older backups shall be kept on the file system. Hourly has the every parameter. It defines how often a backup shall be done. For instance, every equal 5 will create a backup if the current hour is divisible by 5. In other words, at 0, 500, 1000, 1500, and 2000 hours. Weekly has a day parameter, which determines at which day of the week the backup shall be done. 1 stands for Monday. Monthly has a day parameter as well. It determines at which day of the month between 1 and 31 the backup shall be done. The backup will only be done if the respective configuration has been added. We usually do this close to the end of the software training. One final remark about backups. We have just talked about two different types of backups. First, the backup created during the import process to keep original data for some while in case something went wrong. And second, the backup of the whole data, including the database. This shall help you to recover in case you have a hardware crash or a severe software malfunction. This includes issues with critical operations like removing experiments, merging experiments, etc. Therefore, we strongly recommend that you do the second type of backup and copy data to some place on your network regularly. We have reached the end of class 3, except for future videos dealing with Lemna 3D. The next 3 classes are a bit more special. Class 4 deals with special analysis requirements triggered by special sensors like PEM or hyperspectral, or special system setups like risotrons. Class 5 deals with some special topics within Lemna experiment. In class 6, it's all about machine learning. See you in one of these videos.